Okay, welcome everyone. Factoring part 2 doesn't get easier. In general, we're going to be factoring ax squared plus bx plus c, but let's not follow this nice example here because it's not correct, and I'll show you a case of better example. But in general, all we need to know is that we want to factor trinomials in the form ax squared plus bx plus c while finding two integers m and p with a sum that creates our b term and then a product that creates our c term. And then we write it out as this. Um, ax squared plus mx plus px plus c, and then we would then factor by grouping at the very end. So kind of like what we had here previously when we did factoring by grouping alongside additive inverses, right? But we're kind of combining both the first video and I guess the second video together to do this. So for example, if we have a trinomial 7x squared plus 29x plus 4, we notice first we want to identify the terms, the coefficients of each of the terms in our trinomial. Our a term is going to be 7, our b term is going to be 29, and our c term is going to be 4. So same thing still happens. We want to make an organized list of factors of 28 that when paired together give us a sum of 29. So first easy one I think here is, 7 times 4, which is 28. But if we were to add these together, this definitely does not equal to 29. This gives us 11. So what are some other terms like this? We have maybe like 2 times 14, which does not give us 29, gives us 16. But we get our magic number, which in this case should be 1 times 28, which should give us 29. So how do we do this? We then want to write it out in its pattern, 7x plus mx plus px, where m and p are one of these terms, 1 or 28. We input them into our trinomial, 7x squared plus 1x plus 28x plus 4, and we just split the 4-term trinomial into 2 binomials, and then factor by grouping. One GCF here in our first group is just going to be x, while the other in our second group should be 4. Factoring them out, we notice that we have similar factors, 7x plus 1 on both sides, so we can go ahead and combine our x and our 4 together, giving us x plus 4, while also being multiplied by its common factor, which was 7x plus 1. So not too bad, right? Very easy, right? And so the similar things, right? We want to, just to recap the steps, right? We take our a term and our c term together, we multiply them, and we get some nice number. From there, once we figure out what this number is, we then think, okay, what are 2 numbers that make basically our factors of 28 that also make whatever our b term is, right? Which in this case is going to be 29. And so that's what we did here in our list, right? We broke down factors of 28, 7 times 4, 2 times 14, and 1 times 28, and found out that definitely 1 times 28 gives you 29 when you add those 2 factors together. At that point, we input it into our pattern, and then we start factoring, right? Factor by grouping. So a similar thing will happen when we get to 4b. 5x squared plus 12x minus 9. Our first thing that we want to do is multiply 5 times negative 9. 5 times negative 9 gives us negative 45, and so we want to go ahead and think of factors of negative 45 that would also give us a positive 12 if we were to add them together. So let's think about that. We have maybe 1 times negative 45. This definitely won't be it. You would get negative 44, and if you were to swap the negative signs around, you would end up with a positive 44. Same thing if we maybe do 2, can't do 2, let's do 3. 3 times 15, this might be it. We have to make sure that 3 is negative though, so that we get a positive 12. Another last minute one that we could also probably do is 5 times 9, but 5 times 9 would give you 4, which is not what we're looking for. So we'll go with our second option here, negative 3 times 15, which gives you 12 as the sum of the factors. So inputting that into our pattern, 5x squared plus mx plus px minus 9, you just choose whatever which one fits in. In this case, for this example, we wrote out 15 first because it's right next to our 5, and then it'll be more useful for us when we start grouping, right? So we write 15 first here, and then follow that up with a negative 3. From there, we just start factoring some things out. For example, in our first group, 5x squared plus 15x, we factored out a 5x. And same thing here on our second group, negative 3x minus 9, we factored out a negative 3, giving us a common factor of x plus 3. We then combine both the 5x and the negative 3 to give us 5x minus 3 as in one group of a binomial, and then x plus 3 was a common factor, so we also want to factor that out too. Same thing here in this example. We want to do probably the same stuff. 3x squared plus 15x plus 18. Sometimes if we go and do the list version, right? For example, what are like 3 times 18, 8, 16, 24, 54. We have to think of terms, 54 that give us 15, right? When we add the terms together. That might be a little bit challenging for some people, and it might take some time. But if we just look at the trinomial at first, 3x squared plus 15x plus 18, we notice that there are some, a factor that we can at least factor out before we even start doing whatever we're doing here, right? So we notice that 3, 15, and 18 are all divisible by 3, so we can actually factor it out first. 3x squared plus 15x plus 18. If we factor out 3, we get 3 times x squared plus 5x plus 6. And then we can do the two factors, right? We can use what we learned here in the first couple of examples to solve this problem now, right? So we just make a list, right? Factors of 5 that also make 6 when you add them together, right? That should just be what? Whoops, I think we move these around. Sorry about that. Factors of 6 that when added together gives you 5, 3, and 2, right? 3 plus 2 definitely gives you 5 here. Use the pattern, and then we get the factor of x squared plus 5x plus 6 is just x plus 3 times x plus 2. And that's it. Makes your life a little bit easier, but sometimes, like I said, you have to really look at the problem before you even start doing it. Sometimes you can catch these where they do already have a nice greatest common factor that you can factor out, making the trinomial easier to solve. But you just have to really be on the lookout for those kind of problems. What about this problem? 3x squared minus 17x plus 20. In this trinomial, we have a is equal to 3, b is equal to negative 17, and c is equal to 20. But since b is negative, n plus p will also be negative as well. But since c is positive, m times p will also be positive. So we have to make sure that we are picking, two negative numbers that gives you a positive 60, while at the same time added together gives you negative 17. We can try something like 1 and 60, both negative. That definitely won't give you negative 17. It gives you negative 61. You can also try negative 2 and negative 30. This will give you negative 32. And so our middle, the one term that actually does work for us could actually be 4 and I think 4 and 14. But that won't give you negative 17, so the next close bet that we have is negative 5 times negative 12, which should give you negative 17 here. We follow the pattern where we replace m and p for those two terms, negative 5 and negative 12, but it's really going to be up to you how you want to organize that. I'd say to see the pattern, right, if we have a 3 here, think of another number that is divisible by 3 and put it right next to it. In this case, it's going to be 12. Likewise here for 20. We think, okay, what's the term that is also divisible by something similar to 20, which in this case should be 5. So I also want to put that here as well. So the order doesn't really matter where you put it, because you can always rearrange them later on. But after this, we group terms with common factors once more. In this case, it's already grouped up for us, right? We then factor out the greatest common factor. In our first group, it's 3x. So if you factor 3x from this, you get 3x times x minus 4. Here on the right side, you have negative 5x plus 20. The greatest common factor for this is going to be 5, but we take away a negative 5 instead, right? Additive inverses to make sure that they share the common factor of x minus 4. Factoring that out, rather, we combine 3x and negative 5 together to give you this. And we're not adding them. Instead, we are going to be multiplying them. So it should look like 3x minus 5 times x minus 4. Not too bad. Hopefully. I don't know. I think I'm going too fast. But we'll find out when we have those Q&A session on Wednesday, I guess. For number 6 as well, sometimes we can't find a problem, rather can't find an answer. For example, we want to make factors. If we multiply 4 and 5 together, we get 20. So we're looking for numbers that when multiplied together give you 20, but also make negative 3 as your answer. If we were to try to find a pair for this, right? For example, we can do 1 and 20. Right, that doesn't really work out for us. If we make 20 negative, that should give us negative 19. Not what we're looking for. We can try even 2 and negative 10. This gives us negative 8. Not what we're looking for. And we can also do 4 and negative 5, which gives us negative 1, which is nothing. That gives us negative 3. So what should we write then? If we can't find factors of whatever a times b is, that also give you whatever, a times c, which gives you your b term, we would just simply write prime, right? Prime, or however we draw the prime model, right? Right. Just write prime because we can't solve it. And that's perfectly fine. But if you can't solve it, it doesn't mean it's prime, right, all the time. It just means you probably can't solve it. So don't resort to this. You have to really make sure that there's no factors that give you what we're looking for. But that's probably it. We had some nice practice problems to look at. I will upload the video for this as soon as I'm done recording, as well as the assignments. So same thing as what we had previously for polynomials. We'll have probably 12 questions to look at, and then the videos to refer to. Alternatively, I think I'll also be uploading the slides for this in the event that you might need to refresh yourself a little bit more, and maybe look at more examples. I don't know. Anyways.